Here's another example. A shell is fired at an angle theta with the horizontal up a plane inclined at an angle alpha. Show that for maximum range, theta is equal to half of alpha plus quarter of pi. How do we do this? Solution. Let's first use two Cartesian coordinates to explain the question. Here is x-axis, here is y-axis. The plane from which the projectile is fired is inclined to the horizontal at an angle alpha. The projectile's trajectory can be shown to be this, and the point here, say it is P and the initial point is A. The velocity vector of the projectile is say U there, and then the projection, the angle of projection to the horizontal is theta. Now we are to find the theta for maximum range. The range on the inclined plane, say it is R. Yeah, so from A to P is the range there. We will apply the equation of motion that we have shown in the earlier video. The equation is y equal to x tan theta minus gx square over 2u square cos square theta. Let's call it equation 1. Then let me explain here a modification we will need to make to use this equation. If you look at the diagram here, the plane of projection is inclined, so there must be adjustment to x along the x-axis, which is x equals to r is brought to the x-axis, so that is r cos of alpha. Then we also adjust y. The corresponding y now is r sine alpha. Let's say this is equation 2, this equation 3. We need to use equation 2 and 3 in 1 now. So let's say put in 2 and 3 in 1. You can look at the algebra there. We have r is equal to 2u square cos theta, then sine theta minus alpha divided by g cos square alpha. So here we need the angle theta at maximum range. So how do we work through this? When do we have maximum range? Maximum range is obtained when that range does not vary any longer with theta, with the angle of projection. So when the range is not changing again with theta, then we say we have maximum range, and the implication is the r dt equals 0. So we'll perform this action on r here. If we do that, we'll have what we get from there is cos of 2 theta minus alpha, which is equal to 0. We can work around this to get theta out. So from here, you can say 2 theta minus alpha is equal to cos 0. And this gives us pi r cos 0 is 90 degrees, or say pi over 2. Pi is 180, pi over 2. So that is 2 theta minus alpha. So what is theta from here? Theta is equal to, this alpha goes to the other side. That is plus alpha. It is divided by 2 from here. Also plus pi divided by now 4. Now 4. So that is the solution to this problem. I think we have been able to obtain theta as alpha over 2 plus pi over 4. Again, let me quickly mention this. Assuming we have a problem like this, say let the displacement of a particle in one dimension be given as 3t equals to square root of 3x plus 6, where x is in meters and t is in seconds. Okay. Full stop there. The question now is find the displacement, find the displacement when the velocity is 0. Okay, so how do we do this? We are given the displacement relation, or the function that defines the displacement, as the solution as 3t equals to square root of 3x then plus 6. We are to find the displacement, which is now represented by x here, when the velocity is 0. What that is saying is that we are to find displacement when, that is x, find x. What is x? When v is 0. X1 when v is 0. We can interpret that further to mean that what is x when the x, the t is equal to 0, because the velocity is also the rate at which the displacement changes with time. So when velocity is 0, what is x? That is what the question is asking us. So with the equation, let's say the equation is 1, we can make x the subject of formula by writing 3x. 3x is equal to 3t now minus 6. So we can square both sides, square both sides to get 3x equal to, this is 9t square then minus 36, that is 3 times 9 times 2 will be 36, then t, then plus c square, which is 36. So from here we can say x is equal to this is 3t squared minus 12t plus 12. And so what is now the velocity from here, which is dx by dt? So we now say that velocity is equal to 6t minus 12. Yeah, we are told that when velocity is 0, what is the displacement? Find the displacement when velocity is 0. Okay, so when velocity is 0, we have t from this equation now to be equals to 12 over 6, which is equal to 2 seconds. Yeah, this is time for which velocity is 0. Then what is x? What is x when t is equal to 2 seconds? That's the question. So we come back to the equation. The equation is, after resolving, we're able to get it as 3x equals to 9t squared minus 360 plus 36. That's the equation with small adjustment. So x is equal to 3t squared minus 12t plus 12. Yes, when we divide through by 3, so we get this. Now from here, when t equals to 2 seconds, we have x equals to 3 into 2 square minus 12 into 2 plus 12. So that implies that x is equals to 3, what is 3 times 4? 3 times 4 is 12 minus, this is 24. This is 24. Yes, this is 24. Then plus 12. Plus 12. This implies x equal to 0. I think we get 0 here because it bursts out to be 24 minus 24, so which is equal to 0 in meters. Thank you.